Hello, everyone. There were confusions in class today that I think could be cleared up pretty quickly. Um, while I don't think we brought anything close to our A game today in terms of problem solving, I still care that you do well tomorrow. So this is hopefully going to be a pretty quick video. I'm trying to respect your time and go through this as fast as possible, but I'll go through 3 problems that are similar to today. The last one's kind of crazy. But the first 2 are very expect to see this kind of thing. And the last one is kind of like, ooh, that would be a crazy problem if I asked it. The area of a rectangle is 84 inches squared. Its length is 9 less than triple its width. Solve for the dimensions of the rectangle. We know that the area of a rectangle is length times width. However, even though we know the area is 84, we don't know the length or the width. We can't solve something in 2 variables quite like that, so we have to find a way to combine those variables. Well, luckily, we have this statement here. Its length is 9 less than triple the width, so 3 times the width. Now that we have length expressed in terms of width right there, we can use that to substitute a width expression in for length. That gets us here, 84 equals 3w minus 9 times w, which gets us 84 equals 3w squared, because 3w times another w is now 2 w's multiplied together, minus 9w. So I think there were more people stuck here than maybe I expected. So if I gave you a problem like this, I think you guys could maybe solve it in your sleep. But the fact that it was built into a format that you weren't expecting, I think kind of stumped people. So if I gave you this problem, you can solve this a lot of ways. If you subtract over the 84, for example, and get here, I would argue that you guys could solve this by graphing pretty easily. Graph that, second calc 0. You could solve that by quadratic formula in your sleep. You could divide everything by 3. It would be a little gross because that would be -3, but you could complete the square from there. And then as of this week, I think the focus has largely been factoring. Great. So I'm going to complete this by factoring. So I'll come up here so that it won't yell at me. I'll complete this by factoring. So we got 3w squared minus 9w minus 84 equals 0. So I'm going to divide both sides by 3. It's an equation, so I can divide if I want to. W squared minus 3w minus 28 equals 0. So now I'm looking for 2 numbers that multiply to be -28 and add to be -3. I know that -7 and +4 will do the job. So therefore, w equals 7 or w equals -4. So now I'm going to think about the context. I am claiming that the width of this rectangle is either 7 or -4. There is no width of anything on Earth that is -4 inches, so the width has to be 7 inches. I'm going from the inches squared. So width is 7 inches, and I know the length is 9 less than 3 times the width. Therefore, the length of the triangle is 12 inches. I'm going to check my work. So area equals length times width. That is 84 inches squared. So this worked great. That is kind of like the most cut and dry. It is built into a word problem, but it is still solvable way that these can work. It's very often the area of a rectangle because 2 things are being multiplied together. And if I can get both of those things multiplied together to have the same variable, I can build a quadratic every single time. So that's why those problems are going to happen more often. Similarly, 2 consecutive integers have a product of 72. So I would let my smaller of 2 integers be x. Therefore, the greater of the 2 integers would be x plus 1 because they're consecutive integers. If it's a product, we're talking about multiplication. So we need this little integer to be multiplied by this bigger integer. Well, I want to multiply this entire little integer by this entire big integer. So it should be x times x plus 1 equals 72. Writing that in a more normal way, that would look like this, where we would then distribute x times x is x squared, x times 1 is x. And again, like we were getting kind of stuck here, but we can solve these in our sleep. 99% of the time, you want the quadratic to be equal to 0. So I just subtracted 72 from both sides because now that opens up factoring to us. That opens up quadratic formula, which you can only use when it's equal to 0. It opens up graphing. It opens up a lot of things. So the only time we want the constant over here is if we're completing the square. But I moved the 72 over in the interest of doing factoring. So 9 and negative 8 do the job. Therefore, x can be negative 9 or x can be 8. Notice I said or, because if x is negative 9, then negative 9 and negative 8, the number 1 above it, are two consecutive integers which multiply to be negative 72, or sorry, to be positive 72. So that works. My other completely distinct, completely separate option is 8. Well, if x is 8, then x plus 1 is 9. So 8 and 9 are my other distinct possibility. So those are the two sets of values for which those two consecutive integers have a product of 72. Okay, if you want to cut there, you pretty much know what you need to know. That's kind of like the simplest ways to build these, is you need to express both of the values, whether it be length and width, or whether it be two consecutive integers. You have to express them with the same variable so that when you multiply stuff together, you end up with a quadratic equation. Then it comes down to your skill in solving quadratic equations, especially when they're equal to 0. Okay, here's kind of like a crazy kooky challenge one that I thought was kind of fun to build. This was inspired by Bruce and Brody. Shout out Bruce and Brody. So there's an apartment that I built here. And it's doing renovations. It's going to put carpet in the living room and bedroom. As you can see, the study has lovely hardwood flooring. We know that the bedroom is 10 feet long, the living room is 4 feet longer than it is wide, and that it will take 580 square feet of carpet to do the job. What are the dimensions of the living room? Now, before anyone comes for me being like, this is not a real life scenario, you will never know exactly how much carpet you need, but not the dimensions of the house. I know. I totally get it, but like this is the only way the solving works for this type of problem. My brain is as exhausted as yours is. Just run with it. So it's going to take this much carpet to do the job. We know, and I'll label it as I go, we know that the bedroom is 10 feet wide, is 10 feet long. For the purpose of this experiment or this problem, I'm just having length be this way and width be this way. That is not always the case. In fact, length and width are normally interchangeable. But again, just run with it. So length is side to side and width is going to be up and down. I'll push those off to the side. So width is going to be up and down. Length is going to be side to side. I'll probably end up erasing those. So bedroom's 10 feet long. Living room is 4 feet longer than it is wide. So if the living room is 4 feet longer than it is wide, I'm going to call X the width of living room. Because if the width of the living room is X, then the length of it is 4 feet longer than that. 4 feet longer than X. So now I have everything labeled that I need. The only labels that you're not familiar with yet, but this is honestly a really good intro to geometry next year. When two line segments, so this wall of the bedroom and this wall of the study, when they both have those little red dashes on them, that means those two line segments are congruent, meaning these two things are exactly the same length. That's what that's telling you. Okay, so to recap, we now have a labeled diagram. It's going to take 580 square feet of carpet to do the job, and we have to figure out the dimensions of the living room. AKA, we got to solve for X and then do X plus 4. Okay, so how are we going to do this? There's a lot of different ways you can approach this. If you didn't pause to do either of the last problems, I would really encourage you to pause this to try to solve it. There's a ton of ways to solve it. It's a difficult problem, but I think there's a lot of interesting ways to attack it that will work. I'll show you one here. If it takes forever, then I probably won't show you a second. Maybe I can show you tomorrow. But I'll do two if I can be quick. Okay, so way number one, maybe only way, who knows? I've got to carpet this entire area. Well, how much is that area? It is the length times the width. So x times x plus 4. That area is the area of the living room. I also have to carpet the bedroom. Well, how much area is the bedroom? The bedroom has a length of 10 and a width of what? Well, it's half the width of the entire living room, so it's half of x. If I've got the area of the living room plus the area of the bedroom, those together build the entire 580 square feet. From there, it's a matter of solving. Distribute the x, multiply 10 by 1/2 x, and now solve. So we got x squared plus 9x from combining like terms. I'm going to subtract the 580 over to get it equal to 0. And now you could solve this by quadratic formula. Like, you can do that. That said, I'm going to solve it by factoring because factoring is faster. And I know 29 and 20 will work here because I built the problem. So from there, my two options are either that the width of the living room is negative 29 feet or that the width of the living room is 20 feet. I know which one I like better. I'm going to say the width of the living room is 20 feet because no width can be negative 29 feet. From there, we have that the length is x plus 4. So then the length of the living room is 24 feet. And the width of the living room is 20 feet. You can either put width, or earlier I defined it as x equals the width of the living room. I'm not rewriting it. I'm just running out of space. But those would be the dimensions of the living room. Let me quickly show you another way you could attack this by kind of removing the study with its beautiful hardwood floors. Sorry, I'm trying to just go back through all this so that it doesn't delete all my work when the iPad glitches out. Beautiful. Okay, another way we could approach this. We could consider the entire space of the apartment, and we could say that the entire space of the apartment, if this is 10, this is 10. So the entire space in the apartment is length times width, aka x plus 4 plus 10, so the length is x plus 14, times the width, which is x. And so that is the space in the entire apartment. That is all of this. X plus 14 times x. So that is the space in the entire apartment. But I don't want to carpet the entire apartment. I want to carpet the whole apartment but the study. So now I would have to subtract the study. Well, the study, just like the bedroom was, is 10 by 1/2 x. So I could say minus 10 times 1/2 x equals 580. And then this is just another solve. Distribute x squared plus 14x minus 5x equals 580. And again, combine like terms to get here. I'll subtract my 580 over just like before. I would still factor it, but again, you could still complete the square, graph, quadratic formula, whatever the heck you want to, and you'll end up in the same situation where the width of the apartment is 20 feet, or the width of the living room and the apartment is 20 feet, and the length is 24 feet. Hopefully this is helpful. If you have questions about this video or about the topic, feel free to pop in tomorrow morning, like 8 to 8:10, and I can try to answer stuff if possible. It's difficult, but I think there were more opportunities for success than we maybe worked for today. Do your best. Good luck on homework. Email me if you have questions, and see you tomorrow. Good luck.